Hello and welcome to this chapter 4 of the straight line course, Collinearity. Today in this lesson, this video, we're going to be looking at what it means to be collinear, how we're going to be using that in these straight line questions, and how we can prove whether or not 3 points are collinear to each other. And so, it's got the definition at the top here. Points which lie in the same straight line are said to be collinear. So it's got an example down here. A, B, and C are all 3 points which lie on this same straight line. And we know it's the same straight line because the gradient between A and B and the gradient between B and C are equal to each other. So that's what that says here. You can see that A, B, and C in this example are not collinear to each other because the gradient between A and B and the gradient between B and C are not equal to each other, and so they are said to be not collinear. And so this got the test here. If we need to work out the gradient between 2 points, then another gradient, whether or not that's between B and C or the gradient between A and C, then since they all lie in the same point, the 2 lines are parallel, they've got the same gradient, then you can prove that those 2 things are collinear to each other. So let's look at this example. Show that those points are collinear. So show that P, Q, and R lie in a straight line to one another, and so we should work out the gradient between P and Q first. So that is y2 minus y1 over x2 minus x1. So that's 3 over 6. So that is a half. So the gradient between P and Q is a half. Then we should work out the gradient between Q and R. So it's y2 minus y1 over x2 minus x1. So what I'm doing is I'm just making this x1, y1, x2, y2. I generally make the most left one the x1, y1, and the most right one x2, y2. So that is 4 over 8. And of course, we would simplify that down. So the gradient is a half. And there's a specific statement that we need in order to get the full marks for this question. So what we have here is we have the gradients are equal to each other. So since PQ is equal to MQR, the lines PQ and QR are parallel to one another, and since they share a common point, Q, the points P, Q, and R are collinear. So what's really important here is that you have the statement that the gradients are equal to each other, the fact that the lines PQ, as in that line from there to there, and QR, the line from there to there, are parallel to one another and that they share a common point. That is the statements that we need in order to get full marks for this question. So we need to have the equal gradient statement, parallel, and common point. And then you would say that the points, not the lines, but the points are collinear. Okay, let's look at the second example. So this one starts off with the statement that they are collinear. And using the fact that they're collinear, find the value of k, which is in here. So what we're going to do is we're going to since we know that they're collinear, we can make two gradients equal to each other. And it'll be easier in this case to make it so that the gradient of AB is equal to the gradient of AC. So if you had A, B, and C, it's, remember from the original first page, you can prove collinearity by either proving those A, B, and BC are equal, or the A, B, and AC are equal. So the gradients are equal there. So we're going to do that instead because that avoids K coming up twice. You can do either. You could do the gradient of AB is equal to the gradient of BC. It's just a little bit longer. So the gradient of AB, the gradient of AB is y2 minus y1. So K take away -1 over -1 take away 1 is equal to y2 minus y1, 7 take away -1 over 5 minus 1. This gives us k plus 2 over -2 equals 8 over 4. 8 over 4 is just 2, and I'm going to multiply both sides by -2. K take away -1 should just become +1. Sorry about that. And so that becomes a 1 as well. So that negative, so the 8 over 4 changed to a 2. I just multiplied it by -2 to make it -4. Then we take away 1 from both sides, so that gives us k equals -5, which is your final answer.